Hey, it's Mickey, and welcome back to the ModelSpace tutorial series. Today, I'll teach you how to use ModelSpace to conduct a trade study on a power system for your spacecraft. We'll get started by booting up the GUI and initializing our spacecraft. If you followed along with the last tutorial, you should be able to load in that example and use it as a jumping off point for this tutorial. Some key differences for this tutorial are that RAN has a value of 315 degrees, the semi-major axis is set to 7,230,000 meters, and inclination is set to 90 degrees. This is because we're going to analyze a spacecraft that's going into sun-synchronous orbit. This means that the satellite passes over a specific location on Earth at the same local solar time each day. This ensures that the solar panel collected by the satellites each day should be fairly consistent. Also, because we want to study the behavior across multiple orbits, increase the sim time by adding in a numeric input and connecting it to the simulation executive. I picked 43,200 seconds, which is about 12 hours, but feel free to experiment on your own. Next, add in a sun, solar panel, and simple battery system to your simulation. The solar panel requires inputs of frames from spacecraft, Earth, and the sun. Also, we'll assume that the solar panels are body fixed, so create a numeric input and set that to 0. Next, set the output of the solar panel power as the input to the battery system. Add a numeric input and set it to 5.67 watts to simulate the consistent power draw of a spacecraft. To visualize the results of our sim, we need to add in the CSV logger model from the sidebar. ModelSpace is the only simulation platform which lets you conduct trade studies with real commercial off-the-shelf components. Just right-click, configure from default, and pick a solar panel model. These numbers are accurate to the 2024 datasheets provided by these companies. Then, configure the battery system. This time, we'll pick the Eagle Pitcher LP34100. In order to visualize how the voltage on the power system changes over time, we need to connect the sim time output from the simulation executive and the voltage output from the battery system. Next, click Run Simulation and you'll see that you're in a sun-synchronous orbit. Jump over to the Data Visualizer tab that popped open and look at the voltage versus time plot. You'll see that the power generation and draw are fairly consistent. But what if the mission changed and your spacecraft needed to be in an equatorial orbit? Simply change the inclination to 0 and click Run to visualize the results of this scenario. If you look at the voltage plots, it'll show you that the spacecraft is slowly losing power with every orbit, and you'll eventually run out of power. This means that you'll have to make some modifications, such as sizing up your solar panels in order to have a successful mission. Reconfigure your solar panel model to have the Endurosat 6U panel instead, and then click Run. Back to nominal. Let's take a look at that autocoder and see what our script for this power system example looks like. Open up your GUI-config.py to do so. The next video in this playlist goes in depth into the anatomy of a ModelSpace script, so check that out to learn more. Follow along with the rest of this playlist to see all the ways that you can use ModelSpace to help design your mission. Happy simming!